So then, like, I'm super happy to introduce Vanessa, who is joining us actually from back home, which is great. And she's basically going to talk about her super interesting analysis that she did together with Ja on basically the impact of COVID on astrophysics and astrophysics publication trends. So please, Vanessa, take it away. And thanks so much for coming.
Well, thank you so much, Andrina, for the invitation, for this very nice introduction. So today's talk is not really going to be a cosmology talk. It's going to be more of a sociology talk. So together with Jia, who many of you know, we looked at, or we tried to uncover recent trends in our astrophysics community by looking at publication data. And especially we were interested in any changes that we might see in the time before and compared to during COVID. But I think it's all the trends that we see, no matter whether they were caused by COVID or not, I think are worth being discussed and worth being shared with the wider community. And especially we looked at things like disparities by gender, country, and career stage. So if you're interested in looking at in the full publication is already on ArcScience, so you can read the full thing. But so because I really want to invite you, this is kind of almost a personal topic for many of us because we were all impacted by COVID. I really want to invite you to interrupt me at any point and share your ideas and your viewpoints. So with this, I'm going to start with a question for the audience. So what kind of impact do you think COVID had on our work? And to give you some ideas, you could think about things like, did you have an easier or harder time writing publications or working with students? What do you think what were effects that we might be able to measure? So you can just raise your, unmute yourself and raise your voice. I just want to get an idea collection.
I had a look at your paper, so I don't want to cheat.
Oh, but what do you know what you would have answered before you had a look at the paper?
I think
because I was surprised by our findings. Sorry, yeah, go ahead.
So I think what I thought beforehand was that there's a group who was more prolific, and there's a group that's less prolific, and there's a kind of big gap in between. So that's what I thought before looking at your paper.
Yeah, that's kind of what I thought as well. So I had a feeling that I got more productive in the beginning because there were less distractions, and then but then I kind of, there was this wall that I hit, first of all, because it was hard staying motivated all alone at home. It was harder to get inspired because we had no conferences, less discussions. So then there was like this point where my idea was that maybe less new projects were started, so that we would see maybe an increase in productivity and then a drop in productivity. And then another thing that I really felt was that mentoring students was much harder, and I also lost a couple of students who actually took a gap year and didn't want to keep taking online classes during that time. So is that what other people also experienced, or are there any other perspectives?
I'll just say as a parent that there was no time to do anything and just general exhaustion. But or a carer, that would anyone, but that was just a personal experience.
Yeah, no, I think this is, yeah. So we will get back to this later. I think this is a very important point. Anyone else?
One random personal experience was like, for me, especially the beginning, like I was looking at exponential curves, like from the beginning of the day to the end of the day. Like it was kind of like, it was kind of like hard to focus on work while everything else was going on in the world, kind of like, which is like a situation that I find now is exactly the same, but let's close the bracket. But, and then in print, like, I think for me, it was just like also hard, like, like psychologically dealing with everything, and that of course impacts work as well. So that's also something like personal from my side.
Yeah. So we had all of these thoughts when we started this project, and we were interested in, can we actually see any trends in publication data? And there was some initial evidence. So very early in the pandemic, there were a couple of studies. So here's one that was published in Nature Human Behavior. It was actually not an actual publication, it was just a comment. So what these people did is they sent a survey to over 1,000 of researchers in STEM. So this covered many fields of STEM. Very early in the pandemic in April 2020, and they asked them if they had gotten more productive and just generally what kind of impact COVID has had on their work life. And here the result was that people claimed that they had gotten less productive, and specifically, or especially in terms of in their research productivity, they had less time, or were spending less time on research. However, this included many fields, and some of these fields, such as biology, are very heavily dependent on laboratory work. So it kind of makes sense that they weren't able to do research because they actually need the kind of facilities that they only had in their labs to produce research. So this was not 100% representative of astrophysics. They also did, they segmented by different fields. And here, astronomy and astrophysics still saw a negative, a decline in research time, but not as badly as some of the other fields, and even less in physics. And then interestingly, they also disseminated or looked at who was mostly impacted, or what were the factors that mostly impacted productivity. And what stood out was having to care for children, and especially not only having to care for young children, but also having to care for young children and being female. So this was pointing towards the fact that a lot of the childcare responsibilities fell on the shoulders of female scientists. But this was, of course, so this was a qualitative analysis more than a quantitative one, because they sent out the survey. And of course, the people who replied to the survey were also the people who were most heavily impacted and probably felt most strongly about it. But nevertheless, I think it is, you know, just because it's only a small number of people doesn't mean it is not important and should not be addressed. But still, so this was more of a qualitative analysis. Then there was a quantitative analysis also early in the pandemic. This was, again, only a very short correspondence to Nature Astronomy, where some people looked at how many arXiv submissions, or how the arXiv submissions had changed during the first quarter of 2020. They only looked at arXiv submissions by authors based in Italy, because Italy has one of the highest ratio of female astrophysicists. I think it's about 30%. It's among the highest in the world. And so they compared the first quarter of 2020 to the first quarters of 2017, 18, and 19 in terms of total number of papers that were submitted, and then also by what fraction of those papers had female first authors versus male first authors. And they saw this, what they claim significant decline in female authors, and kind of in the impact that COVID had on women versus men in the field. So these were all very initial studies, and preliminary studies very early in the pandemic. So Gia and I, we wanted to do something a little bit more thoroughly. So we went all in and we downloaded all publications, refereed articles and e-prints from the NASA ADS server from starting very early, 1950, until today. So today for us was February, the latest analysis was with data from February 13, 2022. So this includes basically 2 years of pandemic. And we used this previous data to assess the general trends in the astronomy community, and also to be able to correct for these general trends in the astronomy community. So the information that we scraped from ADS was author names, author affiliations, and the publication dates for all of these publications. Overall, we got, I think, at around 1.2 million publications is what we started with. And then we were interested in looking at trends in the community that we can infer from these publications in terms of productivity. It's very important here to note that this is productivity in terms of quantity, not quality, because we don't have a good way to assess the quality of the work. So this just is really measuring how much time do people have to sit down and write papers, not how good the papers are that they're producing.
Should, however, be a correlation there.
A correlation or anti-correlation?
Sure, fair enough. Yes, that's what I meant. That's what I meant. Anti-correlation is what I meant.
Yeah, so it's really unclear. I mean, you look at things as like citations, of course, but then you have the problem that the papers that were published later obviously didn't have enough time to collect that many citations yet. Of course, you can try to correct for this somehow. And then there's also things like networking, and there are earlier studies that show that women get less citations. So there's a lot of things here that we have to correct for. So in the end, we just decided to not try to look at quality, but really just say, okay, productivity is, do I have time to sit down and write something on my computer as a proxy for yeah, how much can I work? And especially if we do a differential analysis where we compare to before, or we compare between men and women, then hopefully the idea would be that they write papers of similar quality. So it's really just about how much time do they have. But yeah, so this is one of the limitations that we have. Another thing that we looked at is how the number of researchers that are entering and leaving the field. And we were mostly interested in recent developments, especially during the last 2 years, which we mark as pandemic years. And we separate with this data, we're able to separate by career stage, by gender, and by country. And it's very important to note, this is the complete opposite to the first study that I talked about. This is a purely quantitative analysis, it's purely data driven. And what we see are correlations and trends, but we have little insight from this data into causation. And that's something that we have to interpret and try to assess after we see this initial evidence from the quantitative analysis. So a few words about data processing or pre-processing. So one of the things that we try to do is we try to decide in advance how we would pre-process, and also what kind of quantities we would look at to not bias ourselves and keep looking until we find a signal. So one of the cuts that we made was we only consider publication with 16 or less authors. This corresponds to keeping about 95% of the publications. And we did this mostly to retain a meaningful author ranking, because a lot of publications that have very long author lists are collaboration papers, where often we have alphabetical order, and also the author lists are usually not really meaningful in the sense that author 23 has not, there's no clear ranking in who has contributed how much to this paper, and we wanted to retain and use this information later. We also tested and saw that our conclusions don't change if we change this cut a little bit, if we do 13 authors instead of 16, for example. And then this was very challenging, and that's actually something that Gia mostly worked on, and she did a really good job on this. We had to identify unique authors, because depending on where you publish, sometimes you only have your initials, you only use your initials and not your full name. So that is one challenge, to match authors or identify authors on different papers as the same author. And the other big challenge is, of course, name changes, because and that is something that we were actually worried would bias our results, because name changes, women are more likely to change their name. Not in all countries. In some countries like Spain, it is usually both partners that change name when they get married. But so we also try to identify those name changes and match people given their first name and given their affiliations, making sure that we don't lose track of them. And then we converted the publication data that we have into an author notebook, where we basically, not author notebook, or an author data set is probably the better name, where we have an entry for each author. And for each author, we keep track of all the publications per year, how many publications this author wrote per year, and in which place, in which author ranking. the date of the first publication of this author, which we use as a proxy for the career begin, the number of unique collaborators over the years in a cumulative fashion, how many people has this person worked with over the years, by looking at the co-authors, and then the country in each year. And we used the affiliation data to get the country. So even though all of this data is public, just the fact that we aggregate it and make it kind of like easily accessible and, you know, have the clear names there with all of the information about how many papers they've written, made us think about, you know, things like data privacy, and we decided to very early on in the stage anonymize the data set, so that even we as in our analysis, we are not able to actually identify people that we know in this data set. So what we did is we very early on assigned a unique ID to each author, and then deleted the name and the affiliation information and just kept the country information. And so this final data set then contained around 260,000 unique authors, and that's the data that we worked with. Are there any questions up to this point or comments? Okay, if not, the next step was gender identification. So we used a tool called Genderize.io. That's basically an online database, and it's an amazingly impressive database. It has it's a database of millions of given names, and if you submit a query with a given name, it returns you not only the gender but also the probability of the gender. And so with this, we were able to assign genders to all people for which we had access to a given name. And then we made a cut, making sure that or only using generation, the probability of the gender was higher than 80%. And this allowed us to assign a gender to 61% of our data sample, and hopefully in an unbiased fashion. And then again, to keep it as anonymous as possible, we actually didn't add the gender information to our author data set directly, but we kept a separate file that matched the author IDs to the gender. And then we kind of did a blind analysis, and only in the last step we added the gender information. Overall, we got in our data set, we have 20% to 80% female to male ratio. This is, of course, the average over all countries and all career stages and all times. But this is already, you know, shows you one of the limitations of our analysis is that once we do separation by country and by gender, that in some countries, we run into very low number statistics. Another limitation, of course, is that this is a binary classification. So we were not able to identify any, you know, non-binary gender identification. So that is something that would have to be addressed with a more qualitative survey-based analysis. So with all of these technical details, I think we can start diving into the data a little bit. So this is just, you know, a first order plot of the number of papers that are published per year over the years. And there's just, you know, already a very interesting trend here, namely that starting from about 2014, we see an exponential increase in papers that are being published. And this trend is the strongest if we look at both e-prints and refereed papers, but even if we only look at refereed papers, we see a steady increase over the years. Interestingly, the fraction of female first authors, which used to be growing slowly but steadily up to maybe 2013, has been kind of stagnant in the last couple of years. So there's no clear trend to an increase in the fraction of female first authors, but we are stuck at about 20%. This is a little bit better for refereed, but not much better for refereed articles. So a note here, the error bars or the Poisson noise is much smaller than all the fluctuations that we see. So all the fluctuations that we see are due to other reasons and not just to number count statistics. Yeah, and so this trend can have two sources. One is we all got exponentially more productive, and the other is, of course, we are seeing an increase of authors in the field. And the first one is the major driver, as we show later. But there's also an increase in productivity per author. So looking at individuals' productivity, what we see is, so there's two different ways of looking at individuals' productivity. If we just count all papers, which we call here N unweighted, which is the number of papers, no matter which author ranking position the author is in, just counting all the papers that had this person's name on in a given year on so this number has been increasing over time, slightly, but and with a stronger increase than the recent years. But this, of course, doesn't necessarily mean that people get more productive. It just means that people network more and that the collaborations are getting bigger and that people appear on more papers, right? That they're more likely to be invited to be another author on some paper. So to correct for this, what we also did is we looked at number N weighted, and N weighted, we tried to come up with a scheme. This is kind of ad hoc, where we try to estimate how much each author contributes to a paper and then downweight. The first author, I think, gets half of the paper, and then the next one gets a quarter of the paper. And so on. And so we kind of downweight the author contributions. And so when we use this weighted contribution to papers, then what we find actually is that the productivity is not at all going up. So it has actually been going down for the last couple of years. Then it was kind of stagnant for a while. And now we see an increase in the last 2 years, which is the pandemic years. And generally, we see here that there's a gender gap, right? So this is, I'm going to show a ratio plot on the next one. I just want to point out that we didn't gender in the colors here. So green is female and purple is male. We actually thought about this. But yeah, with this, let's look at the ratios. So the ratios, I think, is something that is a little bit worrisome. So women are on average only have 90% of the paper output compared to their male colleagues. This is true no matter whether we look at refereed, the weighted paper count, or the unweighted paper count, but there is a little bit of a difference. So if we weight by author contribution, it looks a little bit better. So women are less likely to be well connected or to appear on many papers. This could be due to difficulties in networking, but it could also be due to a difference in seniority. So, of women being more likely to be younger, and there's also the discrepancy is also smaller when we look at refereed papers. So, the men are more likely, it seems, to publish papers that then or have e-prints that end up not being accepted. So possible explanations for this discrepancy. So first of all, I think it's very noteworthy that this discrepancy has been constant over the last 15 years, basically, and that we even see a little bit of a decline here in the last couple of years. So that is not good news. So possible explanations, of course, are higher shares of other duties, such as child and elderly care, household chores, etc. And another point, which I think doesn't get discussed enough, is confidence barriers and productivity impediment by self-doubt, that women just feel less empowered, and this results in a lack of motivation and yeah, just generally more of a psychological barrier to be more productive. So this is maybe a good point, I don't know, where people want to chime in and maybe add ideas or criticize my ideas or discuss. Silence. Okay. That's also fine. That means everyone just.
I mean, it could also be the case that
Yeah.
women think more about, on average, think more about writing comprehensive papers compared to men, probably just dishing out papers, making 5 instead of 2. And then also
Thinking more about communication.
Yes, and also more generally, this could also be part of the uptick in quote unquote productivity, that people are splitting up papers into more than one, where they would have written one 5 or 10 years ago.
Yeah. Because
it's an anecdotal evidence that I subjectively have gathered, I guess.
Yeah. No, I think these are very reasonable points.
Can I ask a question?
Of course.
Did you track at all the length of papers? Because I also have the sense that the number of papers are going up, but their length is also going up.
Good. The length is going up.
Yeah.
We did not look at this, but I think in general we could. Yeah, I think this is data that is also on the ADS server. But no, we have not looked at this. This is a good point. So you're saying it's longer.
Yeah, there's even more growth because papers now are longer. They have a pen. Yeah, I don't know.
So it takes more time to write them because they're longer?
I would, yeah, maybe. That's what I don't know. It seems to me, but maybe it's wrong.
That's a great point. Yeah. No, definitely. Yeah.
And I guess another question that I have is that I think, some of these, how many papers people write and things like this, astrophysics is not completely uniform. Like, I think, for example, the culture in the more cosmology part and other parts is not exactly the same, or things like, for example, author order is not so uniform across all of the subfields. So I just was wondering if you had looked at all into this, and whether or not also, like, my vague feeling is that the female ratio is also different in different parts. But maybe it's not. It's just a gut feeling thingy. But and maybe some things are also correlate with these. Like I don't know.
No, I think these are great points. So I think we were aware of this. We were also aware of the fact that it's of course not true that astronomers do not rely on laboratories, because we need telescope time, right? And a lot of the telescopes also didn't actually have observation time during COVID. So so the problem is really the moment we start splitting, disseminating more, the more the number of statistics go down, and the harder it gets to do gender analysis, because we have low fractions of women. But I think it is true, and it's probably something worth looking at. I would agree with you that probably certain fields, for example, cosmology, have a lower female ratio than other fields. Okay, if there's no more comments, I'll
Did you
move
ever
on.
intersectional analysis where we break this down by the types of institutions people are teaching at or affiliated with?
Yeah, so we did it by country analysis.
Okay. So
This is, yeah.
Oh, sorry, continue.
No, go ahead. Sorry.
Yes, because I was wondering, around the same time the pandemic started, there were all these, various class and racial differences that seem to pop up across different industries. And then I imagine researchers that maybe in astronomy, but at like historically Black colleges or women's colleges might have different output and productivity compared to those at the large state schools or places like Princeton.
No, these are all extremely great points. Again, so that would mean in principle, we have the affiliation information, but then once we start looking at only certain schools, again, the number of statistics go down a lot. But yeah, we could try to do within the US, for example, difference between different colleges. That would definitely be possible. But yeah. So this data, by the way, we have this data, and we're happy to share this data. So if anyone's interested in doing more analysis on it, we're happy to share. We have not made it public because we kind of want to have a little bit of control over what kind of projects will be done with it, and we don't want it to be misused, because it is a little bit, it is a little bit of a data privacy issue, I think, because in principle, one could look at the individual's productivity over time. Sorry, was there another point? Is there another question?
It's just people talking in the background.
Oh, it's just people talking. Okay. Cool. So let's move on. So this is kind of the actual COVID analysis, right? So the actual COVID analysis, what we did is we looked at the number of papers that were published by active authors, where by active we consider having published either during COVID or in the 2 years before, because we see that after not publishing for 2 years, the probability of ever publishing again drops below 3%. So we kind of assume that if someone hasn't published for 2 years, they're out of the field. So 2 years or during is what we consider active. And then we look at the number of publications that people published per month, normalized by the number of active authors, so it is less than 1. And we disseminate by male or female career stage, so having started their career either 1 to 6 years ago, or 6 to 11 years ago, 11 to 16 years ago, or 16 to 21 years ago. And we make this plot not only for the 2 years during the pandemic, which is 2020 to 2021, we also make this plot for 2-year periods before that, where we look at researchers that were at this earlier career stage back then. So it's kind of like a sliding window. And then we get all these curves. And this is for unrefereed. We can do the same thing for refereed. It gets really noisy for women. But the trends are generally the same for refereed. They're a little bit stronger for unrefereed, so for all publications. And here on the left-hand side, we show first all publications, and here on the right-hand side, we show the weighted publication count. And then we have in green again women, and purple again men. And so what we see already by eye is that it seems that during the last 2 years, this is the thicker curve is always more or less above the other curves, and we have this really high axis here, which might be which we don't really know where it comes from. This might be a fluke due to the fact that paper might get redated once they are actually published in a journal. So we might always have this spike of currently published e-prints that then kind of get diluted more over time as things get accepted. This might also be due because this is the early time of the year, so this or late year to early time of the year, November, December, January. This might also be driven by the fact that this is application season. A lot of people are rushing to get papers out. But no matter what is driving this, since we are looking at gender discrepancies or we're making a differentiable analysis, we weren't too worried about this increase here. But even before that, we see for some career stages, especially for the younger career stages, we see that the thick line is usually a little bit above the other lines. Now, there is a general question if this is a COVID trend or whether this is a trend that has started before COVID. And I think there is some indication, which I admit we haven't looked at in detail yet, but we should probably be looking at, that the year before we also see, especially in this category, in this -6 to 11 years, so the 2018, 2019 line also seems to be above the other line. So this trend almost seems to be starting a little bit earlier, at least in this career stage, and especially for men, also a little bit for women maybe. So we are not able to really say that this discrepancy or this increase is due to COVID, but nevertheless it is there, right? So so it is worth assessing it and quantifying it. So the way we did this is by counting, basically looking, taking the average of all of the previous years. So taking the average of all of these, of all of the thin lines that are the previous years, and then just kind of measuring the area, the area between the average of these lines and the line during COVID. And this is what we call excess productivity. So this is the excess productivity during COVID. And then the way we did error analysis on this is by jackknifing and doing the same thing for the other years, basically, and seeing how much variation we get. So this is the excess productivity, and then we can look at things like excess productivity over this error. So how significant is this excess productivity? And then also the excess productivity ratio between male and female. And basically, even though, this is a very noisy measurement because the errors are pretty high, this, you saw the curves, they're pretty noisy. But basically all of the career stages, we see axis A, and B, we see an axis that is larger for men than for women. So overall, even though they're not at the 3 sigma limit, it is in all of these categories. So there seems to be a signal there. And this is true for both I should have labeled this. So this is for the first author publication, and this is for the weighted publication. The only one where we don't really see a big difference is for the very senior career stages. And we see the bigger difference for the younger career stages, where we also expect people, for example, to have young children. So this is the COVID analysis. And then I also promised that to talk about country. So we did a similar thing.
Can I ask a question?
Of course.
Time zero is the first paper, right? So 1 to 6 covers
yeah, so there is
school, right?
Yeah.
Most of it is graduate school.
Absolutely, yeah.
Or half
most of it is, most of it is graduate school. But then it's hard to tell, right? It really depends on country, right? In some countries, graduate school is only 3 years, and others is 6 years. And a lot of our authors are now not from the US anymore. So that's something I can show in the country analysis. So it's actually not really clear from this plot which countries are driving this and which career stages are the most typical ones for these countries. And of course, there's actually a difference in countries between these different lines because the country mixture has changed over time. So there's a lot of things that go in here that one probably could do a regression for or take into account.
So the majority is not US, so we shouldn't think that these trends have. Is it half US or something?
Yeah. No, I don't think so. It might be for some of the earlier years. It might be a good fraction, might be US, but it's not for the later years. We are now starting to be dominated by China mostly. China and Brazil are starting to be really big.
But for example, in the case of China, both the pandemic and culture might be quite different. So I don't know.
Yeah, no, it's very hard to tell. I have numbers for the US. So the next panel, we look at US. We see similar trends for US, but they're not as strong. I think the US actually didn't have that much that strong signals from what we see in the next analysis. Yeah. So that's a really good I think a way to go to the country analysis or to introduce the country analysis. So the next thing that we did is we tried to separate this by country. So here in the above line, I'm going to walk you through it step by step because there's a lot of information on this plot. So in the top panel, we have world. So this is just the average over all of the papers that we have. And here in the first line, so we look at the 2 years during COVID and we take the average over those two years, where for us, COVID started in February 2020 because at that point, for example, China was already shut down. So also the beginning, of course, is a little bit, there's a little bit of noise here in the beginning, but we just defined February 2020. So we look at the 2 years, and then we compare to the average in the, I think, 5 years before that, actually. So that's maybe something you could criticize. We could you do 2 years, we did 5 years. And we look at the number of, so here just the number of papers, average number of papers per year that were published, and we look at the ratio of during COVID to before COVID. And we rank order here by a country that had, by how much change the countries, different countries were seeing. So we only look at countries for which we had at least 1,000 authors, so that the Poisson errors are small enough so that we can actually, these things are more or less significant that we are looking at. So we never have more than 10% Poisson errors, I think, on these things. If we put in the error bars, this becomes a mess to look at. So we kept the error bars out, but it's maximally 10%. So looking at this, so the number of papers, and this is not corrected by number of active authors. So this is really just the number of papers. And as you can see, really the driving ones here are China, India, and Brazil that are seeing, and probably arriving in the last couple of years. And US only had a very small increase in number of papers during that time, and it's unclear whether this is probably within error bars. We also look. We look at this quantity, or we look at the fraction of female authors, first authors by country here. And we saw before that this is on average at about 20%. And here, the way we color this is, so gray is before COVID, and then the colored points is during COVID, and they're green if it improved, and they're red if it got worse. So everything that moved to the left is red, and everything that moved to the right is green. And here, I think the results are a little bit mixed. Generally, there's maybe not that many. So US there seems to be a slight improvement, but again, it's unclear whether this is significant. I think there's the most significant ones we're probably seeing in Iran, which is interesting. Way higher fraction of female first authors in the last couple of years. This is probably not connected to COVID. There's something else going on there, some sociological trend or some, yeah. So if anyone has insights on that, I would be really interested in hearing about this. We also saw improvements in Sweden. We saw improvements in South Korea. And interestingly, Brazil, India, and China, even though they're worse than average than in the world, there has been some improvement. Apparently, there's a general trend to improvement here, and otherwise we had a little bit of decrease. But I don't think there's like a clear. I don't see a clear message here in terms of the fractions.
This is during COVID versus what? Versus before?
So this is the five years before COVID average.
So there are 2 points per country. This is why one.
Yeah, so the gray is before COVID, and the colored point is during COVID.
So it's 2 years and the previous 5 or something like that.
Yes, exactly. Yeah.
Can you divide like the pre-COVID into like 2 bins? Like maybe in like China, India, like things are accelerating. So I mean, it's just like the accelerating trend already present.
Yeah, we could probably do this. I mean, that's part of this is also, we didn't want to do too many things after we had the results. This was kind of the plots that we had decided we want to do before we did this analysis, and then we didn't want to like try to group things according to what the data was telling us and so on. So yeah, we were a little bit on the fence, but yeah, and I mean, it is always, if since we are not in these countries right now, and we don't really know what's going on, we also almost in many cases didn't feel like we had enough knowledge and insights to decide which countries should be grouped together. But you're saying which ones would you group together?
No, I was just saying, I mean, there could be a trend which was going on pre-COVID, like just the number of publications increasing, and that might just be reflected in the.
I think so. I think so. I think that a lot of the trends that we're seeing are actually probably not COVID trends. Maybe for some countries they are, but I think for especially for Brazil, India, and China, I think these trends have started earlier, and they're probably also another thing that we could correlate with. And we at some point also even scraped some data, was looking at how much these countries are investing in research right now. So what is the share of the GDP or whatever that they're investing into fundamental research. And I'm pretty sure we would probably see a correlation there.
Okay, thanks.
I mean, I agree that most trends take a long time, right? Because how long it takes to create a science.
Write a paper? Yeah.
It takes a very long time, right? So I can imagine some catastrophic thing of COVID showing in a 2-year differential, but like long-term things, probably you need to wait 5-10 years to see some big change. I'm guessing, I have no idea, but yeah, because just how long it takes for somebody to become, like probably the peak productivity in our field is some postdoc level years or something.
Matthias, you're always taking away, like you're always projecting into the next point that I'm trying to make. Sorry. No, this is great. You're really thinking ahead. So so this is actually the next plot, which is, as you can see, all red, and this is something that I think is going to impact us in the future. So this is the number of new people that have entered the field during COVID. And so entering is maybe the wrong word. Names on publications that we see for the first time during COVID versus pre-COVID. So this means that in basically almost all countries, people are either having a harder time even getting their first project or entering the field, or, and which is probably the most likely one here, is to finish their first project. So there's this entire generation of people who've started their PhDs, or probably are in the early PhD phase, that during COVID were not able to be as productive and learn as much and as before COVID. And that is also true in the US, by the way. So that's something that we can also take away and I think is something that also we all felt, right, when we were mentoring our students. And in terms of female fraction here, again, I think it's very mixed. So there are some countries like Chile, which had actually an increase in female fraction, Iran again, and then there's some which have a decrease, which is, for example, Poland, Japan. US, again, I think there's not really a clear signal here. There might be a slight improvement. Another thing that is worth mentioning here is, so here you can kind of get a feeling for the numbers, because so the worldwide average is positive, even though all of these here are negative. So that means that China, in terms of numbers, is really driving this. So it's basically China, Japan, and Taiwan together are kind of outweighing all of the authors from the other countries in the statistics. So there's a lot of influx from China. Okay, so this is number of new researchers. Then the next one we have is the number of papers, so the individual productivity, basically. So the weighted average number of papers that were written. And here our finding is that it seems like there's overall an increase in individuals' productivity, which is kind of surprising. That's something that we did not expect. So people are, even after correcting for the fact that people, so this is the weighted one where we kind of like give the first author more weight and then less weight to higher other authors. So we're correcting a little bit for this networking benefit. Even here we see an increase in productivity overall. Except for in a few countries, and I think so the US here is just a little bit better, but basically we didn't have a negative impact, it seems. that is not completely true when we look at, again, the gender ratio. So here's something that's really interesting, is that there were only a few countries, and that those were, well, maybe Taiwan, Australia, Netherlands, and Switzerland, where women were as productive as their male colleagues before COVID. And now in all of these countries, the trend has been away from this. So now women are less productive than their male colleagues. And maybe the Netherlands, it's still roughly the same, but in all other countries, we're seeing that this gender disparity has basically widened. When we look at unweighted papers, again, so this is total number of papers. Again, we see higher productivity. Here, again, the female to male ratio is a little bit more mixed. So it seems like there were some advantages to women in some places, where actually there was a huge jump here, for example, in Belgium, and another huge jump in Poland, where some people must have benefited a lot from networking opportunities during that time, and have ended up being on more papers. Right, so this concludes the by country analysis, and that's kind of the end of my talk. So just to summarize, so I think we uncovered some long-term trends. I think we're seeing an influx of new researchers from some countries. That's for sure, and those are mostly India, China, and Brazil. We see a trend to more networking, and the bad news is we see no trends that point toward overcoming kind of persistent gender disparities, but more of a stagnating trend in overcoming these disparities. Short-term trends, I'm calling them short-term because we don't know whether they're actually due to COVID, is increase in individuals' productivity, barriers for young researchers to enter the field or to complete their first project, and again, a widened gender disparity in nearly all countries that we studied. So with this, we can have more questions and more discussion.
Thank you so much for this really nice talk, Vanessa. Are there any other questions for her?
No, where do you go?
I was just going to ask, have you all thought of expanding this analysis into considering how other like underrepresented minorities in academia have fared under COVID, and like I'm sure that's something that's top of mind, and it's a giant undertaking, and especially harder to do without things like maybe like the AASI self-reporting of URM status is like maybe one tool that I know in the department we've talked about using in some instances, but like how would you even think of going after that?
Yeah, so that was an excellent question. I think so this was our first kind of, well, maybe, or for me it was maybe the second sociology experience. So in a way, we also tried to make a cut where we still felt comfortable, right? Because where we still were like, okay, this is just a data analysis, and we're not touching any topics where we actually have to think a lot about interpretation and going more into the qualitative analysis. I think with things like other minorities, which we, it's really hard for us to get any information from the publication data itself, because names only tell you that much. Or yes, maybe we could look at affiliation and correlations with income levels of typical students in this college and so on. But I think in the end, probably what one would have to do is to complement this with some kind of survey. So we were also kind of wondering if we should use this and the kind of initial analysis that we did, maybe even to identify certain people, right? And then specifically target maybe a survey to certain people to get more information on what are driving these trends. But yeah, I think the way to go would be to start collaborating with sociologists. So we have reached out to cosmologists, sociologists, and we've gotten feedback on the paper already. So it's kind of like we kind of learn as we go and see where it takes us, and also see where if sociologists think that this is interesting, or they're like, oh, we know all of this. Like, you should just look at this paper from like the 1990 or whatever. No, I mean, these are of course recent trends, but yeah, so we are exploring, and there's definitely a lot of interesting things to look at. There's also, of course, the other big question, how much you get appreciation for doing this kind of work, because I think we all agree it's very important and we all think it's very interesting, right? But we also have to think about publishing in our own fields and then getting publications in our own fields. So people already ask me things like, but where do you publish this? Like, how does this like add to your publication record? So there's this other kind of problematic that I think, it makes sense to collaborate with sociologists who actually can benefit from doing these kind of analysis also for their own career.
Vanessa, I guess a comment on this gender disparity that I think, I don't know, my personal view it's okay. I don't mind if I write fewer papers than someone else, as long as someone doesn't judge me on the number of papers I've written. Right. Yeah. So this idea that we have to necessarily overcome number of papers productivity, not clear to me that we have to overcome that, but I think it's really important for pointing out to, hiring committees and stuff that just exists for whatever reason.
So so because of that, motivated by this, I tried another thing, which of course was not working because there's not enough information on this, but I tried to train a random forest on predicting whether someone's going to leave the field or not, given all of this information. And the reason why I did this was because I was interested in doing an importance analysis and seeing what are the factors that people look at, right? I mean, we kind of know a little bit, but also just seeing if we can get from the data, is it important for people to collect, it important for people to have a lot of papers, what are kind of and maybe even the gender, do I see that the gender is important in this analysis? But yeah, so the thing is, it's hard to predict whether someone leaves the field or not, because some people are really good and leave the field just because they get an even better opportunity outside, or because of other private reasons. So it's really hard to make the prediction, but the random forest that we trained had like a 65% accuracy. So definitely number of papers was one of the like more determining, was I think the most determining one for staying in the field or not staying in the field. So no, I completely agree with your point, and that's why it's really important to discuss these things, because in hiring committees, that's something that we definitely have to take into account, right? And try not to be biased by this, because we know that women are just less likely to publish as much.
So one comment for me, I mean, I think my conclusion, tell me if it's completely off, but my conclusion is that the effects that you found were relatively small, given the massive, thing that happened. So I see it as a little bit optimistic, right? I think that if you were to look in other parts of I don't know, for example, you read primary school, the number of kids that actually completely drop out and disappear. I don't know, it didn't sound like you found that it was so, given the massive disruption of society, at the end of the day, it seemed that astrophysics saw just minor changes which were comparable to differences between countries that existed before. So it seemed to be more or less fine. I don't know, maybe it's just,
No, I agree. I agree. I find the most interesting thing is more the kind of like long-term stuff that we see, like, that gender ratios are not really improving in the last 15 years. I think these are the things that seem to be there and very persistent. But yeah, no, it's true. We're fortunate, probably.
I mean, this fact that fewer people are entering the field, I think that's, and it seemed to have been everywhere. I think that's kind of an interesting point that would be nice to see if it continues or if it's related. I assume that if you were to look at other fields, you would see similar, because, I don't know why it would be so special about astrophysics. Probably something about going to graduate school in such a time, or I don't know.
Yeah, I mean, this is probably correlated also with funding. I mean, again, anecdotal evidence. I know that that schools in graduate admissions, schools hired less people in last year than they did this year, because I had some students who didn't get into grad school last year, and then got into several ones this year. So, and yeah, I think it was just like financial uncertainty from the side of the universities too.
Also, I believe there's issues with visas and people coming from abroad, that which it might be a big fraction of students overall in the US at least. And that was significantly more difficult. So I don't know if that's related.
Yeah, great point. Yeah, so in principle, we would have to do this again in maybe 2 years, and then maybe in another 2 years, and just see what the long-term effects are. And I have this one plot here where we looked at idling times, like kind of, what's the probability of someone not publishing if they've published before. And we looked at it over time, and we also plot the GDP here. And there seems to be a slight correlation. And I think specifically the one that is probably the most, or anti-correlation, and the one that is probably the most significant is 2008. So here we were interested if we were seeing something like we did see in maybe 2008 during the pandemic, but there doesn't seem, we don't see anything yet, but this is also a plot which might be interesting to make, to extend into the future.